Now let's see this question. This question came in GATE 2014 for 1 mark. The question is, let G is equal to V comma E be a directed graph where V is the set of vertices and E is the set of edges. Then which one of the following graphs has the same strongly connected components that of with respect to that of G? Okay, so G1, G2, G3, G4, these are the four graphs which are somewhat alterations with respect to G, and we have to say that which of these graphs has the same number of, not only same number of, exactly same strongly connected components. So whatever in G we are having strongly connected components, those the exactly same strongly connected components should be in that answer. Okay, so we have to choose that one. Okay, so let's start. The first one is G1 is equal to V comma E1. So V is the same, so set of vertices is same as that of G, but E1, the set of edges is different, where E1 is defined as U comma V, where U comma V does not belong to E. Okay, so we'll try to understand it with an example. So let's say consider a graph which is, let's say there are two isolated vertices 1 and 2 and there are no edges. So let's say this is the graph G. Okay, so if this is the graph G, then with respect to the definition given in 1a, what is the graph G1, that we have to understand. Okay, so here they are saying that the set of vertices are same, so the set of vertices are same and the edges are such that if U comma V edge is not there in G, then that is edge exists in G1. Okay, so 1 to 2, that edge does not exist, so it will exist in G1. 2 to 1, this edge does not exist in G, that's why it will exist in G1. So this is the graph G1. Now we can clearly see that G has two strongly connected components, each having one vertex, and G1 is having only one strongly connected component. So definitely 1A is not the answer. Okay. Now if we talk about D, then if we make G4 for the same graph, then see, they are saying that the set of vertices is such that in G, the vertices which are not isolated, they are part of the G4. Okay, but in G, we are seeing that all the vertices, in fact both the vertices are isolated vertices, and that's why as per the definition in G4, both of them should not exist in G4, which means that G4 is basically a empty graph. So there are no vertices and no edges. So G4 is a empty graph. Now clearly D is also incorrect, because now G has two strongly connected components and G4 has no strongly components, zero strongly connected components. That's why D is also not the answer. Now let's say, what if the graph is something like this? If the graph is something like, let's say this is 1, this is 2, and if the graph is something like this, there is only one edge from 1 to 2. Let's try to understand how G3 will look like. So if this is G, then G3 will look like, as per the definition, the set of vertices are same. So 1 and 2, the set of vertices are going to be the same. Now the set of edges, the definition is U comma V, such that there is a path of length less than or equal to 2 from U to V. Okay, so from 1 to 2, there is a path of length 1, right? That's why this edge will exist. Now from 2 to 1, there is a path of length 0. So this will also exist, because 0 is less than or equal to 2. So this will also exist. Now again we see that G3 has single strongly connected component. Okay, basically the strongly connected component, you have to refresh the definition of strongly connected component. Strongly connected component is such a set of vertices in which every vertex is reachable from any other vertex. Okay, so here 2 is reachable from 1, but 1 is not reachable from 2. Okay, that's why these are basically different components. But here 1 is reachable from 2, 2 is reachable from 1, and so this entire thing is basically a single strongly connected component. Okay, so now we can understand that C is also not the answer. So obviously B is only left and that is going to be the answer, but let's check that. Okay, so in B, let's try to understand with a example where there is a edge, let's say from 1 to 2. Okay, if this is G, then what is going to be G2? G2, they are saying that the set of vertices is going to be same, so 1 and 2, and E2 is U comma V such that V comma E is an edge which exists in the original graph G. So if 1 comma 2 is an edge in G, then 2 comma 1 is going to be an edge, so 2 to 1, that is going to be an edge in G2. Now see, now this also has two strongly components and this also has two strongly components, so this is definitely the answer. We can check it with some complicated graph also. See, let's say there is a graph something like this, let's say, okay, so let's say this is G, then what is going to be our G2? Our G2 is that the vertices are going to be the same and basically the edges will be reversed, right? So the new graph will be something like this. Now see, we can clearly see that in this graph there are two strongly components. One is this strongly connected component and another is a single vertex, this. Okay, and in this graph also we can see that this is one strongly connected component and this is another one. So we see that when the edges are reversed, then the number of strongly connected components, and not only number, exactly the same set of vertices which are there in G, they are forming exactly the same another set of vertices which are forming another strongly connected component in G2. Okay, so basically the answer is B.